Hi, today I will show you how to build a flow controller for pouring a specific amount of liquid repeatedly by connecting a flow sensor, a valve, and an ESP8266. You can precisely, with this I can precisely measure water easily, fast, and with a do-it-yourself solution. And in this video I will show you how you can build one yourself. This system with a flow sensor control, a water valve, an ESP8266 and a relay, you can, for less than $10, make the same. So you could have several working at home. And I will go inside the detail to show you how to build it and what's the components. So our problem here is how to repeatedly measure a specific amount of liquid. There is some expensive controllers that can do that. I can show you what model. And this problem happened specifically for me in mushroom cultivation, maybe in other agricultural area as well. So the idea here is that we got bags of substrates like this one. Okay, we want to add the right amount of water inside each bag, and I have like 25 bags in front of me. So you'll have to find some way of measuring. So the classic way to do that is by using a scale. So before we have this system, we use the scale method. So just put your bag in there. I know that I must add 1.8 kilo of water. It's a bit difficult with only one hand to do it, but you see as I'm pouring the water, the weight is decreasing. And almost there. So I need 1.7, 1.8. Okay, I need a little bit more. It's because it's checked. Okay, so this scale is not the best. Okay, I'm at the right weight, and this is the bag with the water inside. And of course I have to do that with all these bags you see in here. Maybe not so very well, you don't see very well, but I have 25 bags like this. So doing this one by one, it takes some time, not very much, but why to waste it when we can have this super system that can help us save it. So another option is actually to use the water line here. So this is supposed to be the right volume. So I will start filling the water, and I will show you that it is not easy. So you can see the water filling up. Okay, and I will stop just at the right moment. It's about here. Okay, this is the other method. It's much faster than with the scale. Now I know more or less that I have the right amount of water, but be careful, because if I start moving, then yes, I'm unable to say if I'm at the line or not at the line. And that was one of the problems I had when using this method, that you need to be perfectly still. And then I can add this, put it in the scale. You can put it in the scale to check the weight. Okay, it's 200 the plastic can, and so it's more or less the 1,750 that I need. And now I will add the water inside. Okay, this is the method we used before having a flow controller, but with this solution it becomes very easy. I just have to grab a bag. Okay. Bring it here, put it here, press the button, hold it a bit because it may fall. And while it's filling up, I have to wait. And then when it's finished, it's over, it had the right amount of water, and it's done. Now, maybe I won't use this method because I will be moving the bag here and moving it back there, and probably this will go into our machine up there to fill the bag filler, so that the substrate will go inside in the same time that the water. But until then, because we have some things to do before, what we'll use is simply to fill inside this, because I won't move the substrate around. This way I will just move the water. So I will have this, and while it is actually filling the next one, I will go to empty it and bring back the empty one. So now I'm going to fill. Okay, that's it. I have some bags to fill now. I will show you a bit the interface. I will go into the detail later where you can change the volume and connect to your local Wi-Fi if you have one, and even, I don't know, start... Oops, it's starting! Shit, how to stop it now? System. So the components of the system, there is first this flow sensor. I will put the reference in the comments of the video. And there is also this water valve. So this is a standard 3/4 of an inch water valve. This one is AC water valve, so it's a big cable there. And we have also the button just here. So this is standard button. It's a big one, so not easy to miss. And we have also the ESP8266. You can see it inside the box there. So it is there, it is connected. This is a Node MCU E12. It's connected with USB, and it's connecting the button with the flow sensor and the valve together. And the last component is this relay you see at the bottom there. So it's standard B-canal relay. I use only one canal of both, and it is connected to AC current. This is the big cables you see in there, and the power is coming from there, going through the relay, going very far, and finally getting to the valve here. And so when the relay is on, I can show you it is the ledge of the relay is on, and the water is on, and when it has reached the right volume, it stopped by itself. So that's it. So this is the different components of the system, and they are connected together. I will go. I will give more detail on the connections later. Let's have a better look at the interface. So this is running on last century iPhone. The interface shows the current volume. So the current volume is only 2055. It shows the limitation 2100, and it shows the current flow and the state of the relay. You can start the system by pressing the start button, or it's like the physical button. It's the exact same function. And underneath there is some information like calibration here. So this is the calibration. The value is a standard value for this sensor, but you could change it if you have a different flow, for instance, because it will affect the volume. So it's how much the sensor is sending pulses and how much pulses is converted into milliliter here. And the last one is the stop offset, is because actually it takes some time to stop the water. So when I tell him to stop 150 ml before this 2100 value, so it means 1950, it will stop. But even if it stops, the water continues a little bit, and there is 100 milliliters more. So I should change this value to match the stop offset, to match what is so that the volume, when it stops, matches the limit. So okay, this is the interface. There is also the Wi-Fi configuration. If you put in there your router Wi-Fi name and the password, it will connect to your router instead of creating its own Wi-Fi. If it doesn't manage to connect to the router, then it will create this flow control Wi-Fi network without any password, and that allows you to connect there and see this interface. Just a word about the address. This is MDNS. It was called flow control. So if you have an MDNS device like an iPhone, it will work, but or else you will have to use this address underneath there. With numbers. Or else you can use the MDNS to access your boards. Okay, so this is the interface. Now I will show you a little bit the plumbing. Okay, so the plumbing is quite easy to understand here. The water is coming from here. There is a tap that is currently open, and then it connects to the flow sensor, and then there is another connection that goes to the water valve, and then another connection that goes into this corner, so that I have the water vertically. I don't have to have the whole system vertically. It's not practical in this place, but this corner helps to do that. And besides some leaks when it's running, some drops, it is working well. I don't know if maybe the position of the valve and the water flow could be reverted, but I'm not sure if it is better like this or the opposite. So while I'm at it, I will show you the power supply side. So here I used this AC valve, but don't use the AC valve because it's quite dangerous. Instead, try to find the 12 volt DC valve, and here we have
electricity plus water equal danger.
The power coming from here. All this connection, two of them are DC 5 volts going to the relay and the ESP separately, and the other is the AC that is going to the relay and then to the water valve. So I will just show you. There is a long cable there, and I'm using to connect all my sensors. I'm using these jack relays, jack connections, so I can unplug the whole system with jacks, and I use for both of them. I think there is a jack that, as you can see, go to the button, and a jack that goes to the flow sensor. There is no jack that go to the there is direct connection inside, and you can see my prototyping box. It is quite easily made. I mean, it's not something professional. It just I fit all the cables in there, close it, and it's done. It's of course for prototyping. And now I will show you how you can install my program on your ESP8266 if you have made the right connections. I will show you also how to install it, and a little bit of the code. So just before stopping, last water, okay, it's running, and it's smooth, it's great, and it's easy. You can do it yourself. Hi, so I will show you now the code. So this is available on GitHub. You can get it at this address there. I will add it to the comments somewhere. And it's a quite short piece of code, just one page, as you can see here. I'm scrolling up to the bottom. And I will go a bit into the details. So first, you can see this part is just for using MDNS. In case you don't want to use MDNS, you can change the default MDNS address. And then there is a literal interruption manager here. The goal is to place hardware interruptions because the flow sensor react to generate pulses, and so you need to capture these pulses, count them, and so on. And then there is a little object button that react when you press the button, and when you release the button, that can reset the counters and all that. And yes, also this button you need like to keep pressing for a little time to get to filter out the, when to debounce the button. And then there is a little class, the flow. This class actually, like, there is the default calibration here, and it will place the interruption, like you can see here. It will attach the interruption, and then it will count how many interruption pulses has happened. And there is few functions here, like to get the volume and so on, change the calibration. And then there is a little class for the relay, which just like make a digital write on and off. I think my relay is reversed, so when I send low on the right pin, it will stop. It will start, and if I send high, it will stop. And then there is a little manager for the Wi-Fi, the one that take care of connecting to current Wi-Fi station, and if it doesn't work, it will attempt to create its own hotspot, and this hotspot will be named flow control as well, I think. And then okay, we have a little function here to check what the user is returning, and okay, all this is useless. It's in comments, and then it will, this little class will save the configuration into the EEPROM, so that when you shut down and start it again, it will keep the calibration values and the volume, the target volume you want to reach. And then here you have a little, this is actually the HTML code for the page. So it's very long line with all the code, so there is no need to transfer like as a separate file. It will just okay, it will just display the page is here. You can see it also right here. So it's the same page in case you want to change something in the page. It's mostly JavaScript. So the JavaScript is creating the page and creating the fields and writing everything, and then starting communicating with the ESP to make to update the values that the user enters. Okay, I have a little problem here. We'll open it again. Okay, so we are back in the main C++ file for Arduino. Okay, and we were at the JavaScript HTML file that is embedded inside the code. So then there is this little class, the flow server, that makes all that makes the server. So it will handle the request, it will create the MDNS, it will I don't know, rename the MDNS, save the settings, so it will save everything into the EEPROM. And it will handle the different calls from the JavaScript, such as starting the water, stopping the water, setting the limits, erasing the EEPROM, save the configuration, change the calibration, change the Wi-Fi to station or to AP, and finally give back the data as a JSON for the JavaScript to display it on the page. And it's more or less it. At the bottom here, it may be of some importance. I said I will show the connections, but honestly I don't remember much. It's been already 2 years I made this code, so I don't remember how I wired it exactly, but here you can see where you need to connect. So like the button, you need to connect it to D3, the flow controller, the flow sensor to D2, the relay to D6, and of course you have to find them on your model of ESP8266 because they don't all have the same layout. And that's it, and you have like okay, this is like the listener from the button, and so
I don't remember why, but I did one listener for the press and another for the release. Anyway, and there is also a listener for the flow control. When the flow changes, it will just print actually the new value of the flow on the console. And finally, of course, where everything starts is the setup function here. It will do all the job of initializing the serial, and then it will connect the Wi-Fi, and once it's connected, it will the Wi-Fi. I mean, it will connect to the Wi-Fi or create the hotspot, and then create the relay, create the button, put subscribe the listeners to the button, subscribe the listener to the flow, and what more? Yeah, load the saved calibration and volume values, create the server, and start the server, and that's it for the setup. While the loop, it will be very easy. It will just call the yield function of the server so that it can run, and just display some dots on the console. That's it. This is the little code of the flow controller. So with this, if you know a little bit of code, you can just start with this or make your own. It's very easy. It's very short. I mean, it's just like one long page. It's 700 lines with maybe even less if we remove the part in comments. I should have removed. And okay, I will just show you just a little bit more, maybe in detail, the JavaScript. So of course the JavaScript starts here. So on load, it will start the script function that will just load the JSON from the server, and it will do so every 3 seconds. So if you want to make it load faster or slower, you can change here. Of course, if you change here, you still need to minimize the code and put it back into the other file, because or else it will do nothing. And it will and so we have one function to update each time we have a new data JSON file loaded. It will update all the values, and the first time it will create all the what you see in the page before in the video. And you have all the little calls for changing the limits, calibration, yes, the calibration, to press, to start the relay, to change Wi-Fi and all that. So with this, you are good to use my code and build your own flow controller for $10 or less. Anyway, have a good coding, building to make your own flow controller, and I hope you enjoy the video.